Start.
Yeah, I'm sorry. I was thinking 2:15 and I put 2 on there. But they, like I told them, Rachel, we get in at 2. So you sit down in your, tardy bell at 2. So it gives me a little bit of time. All right, so let's go ahead and get started. 2.1. Um, this is more of the math work. So last chapter was not a lot of math. This turns out to be a little bit more, and a lot of it is on your calculator. So if you have your calculators, you want to have those with you. Um, Here are the scores of the 25 students in Mr. Pryor's statistics class on their first test. So all of these were test grades in his class. The bold score is Jenny's 86. How did she perform on this test relative to her classmates? So make a stem plot that displays the distribution. So how do we make a stem plot? And you can answer on Zoom or you can answer in class. Don't feel like it's any different, okay? So how do we make a stem plot?
You put the first number on one side of a line and then all the other numbers in order from least to greatest on the other side.
All right, so what number should we start with on this one? Look at our scores.
6.
Yes, because it's the least. Now my question is, should I make it like 6, 7, 8, 9, or should I make it 6, 6, 7, 7, 8, 8, 9, 9?
6, 6, 7, 7.
Why would I do 6, 6, 7, 7, 8, 8?
There's a lot of 8s and a lot of 9s.
Yeah, there's actually a lot of
Not many
sevens and a
9s.
lot of, yeah, a lot of sevens and a lot of eights. So I would split it. Do you have to?
No.
No, you don't have to, but I would. Okay. So we don't have to do 2 6s because there's only one value for 6 and it's the upper value. If you would have had a 60 and a 67, you would have to split them. Okay. But we don't have anything lower than the 67, so we don't have to split it. So then we're going to do 2 7s. And I'm going to go ahead and tell you what they are. Remember, we go from 0 to 4 on the first 7, so 70 to 74, and then on the second one, we go 75 to 79. So we have a 72, 2 73s, and a 74. We have a 75, 3 7s, an 8, and 2 9s. We have 2 80s, an 81, 82, 3 83s, and an 84, 85, 86, 89, a 90, and a 93. We don't have to make a second 9 because it doesn't go any higher than that. What's the last thing I need to do?
Do a key.
And what's our key?
6, 7 equals 67.
Represents, remember we have to be in detail, represents what?
A score on the first test of a statistics class.
And then make sure you define it. A score of 67 on the first statistics test. All right. Notice that the distribution, again, I like to look at these kind of sideways. If you're looking at what it is, roughly skewed or symmetric, roughly symmetric or skewed left or right. This one is roughly symmetric. With no apparent outliers. It doesn't look like there's too many high ones or too many low ones that stray from the data. From the stem plot, we can see that Jenny did better than all but 3 students in her class. This mask is making my nose itch. So one way to describe Jenny's location in the distribution of test scores is to tell what percent of students in the class earned scores that were below Jenny's score. That is, we can calculate Jenny's percentile. All right, so just to throw this out here, percentiles, like when you were younger and you took like test scores and you got in the 99th percentile, that means you were 99% smarter than everybody else that took it. So you were in the 99th percentile. You can't be in the 100th percentile because there's always like, you're the 100, if that makes sense. So you did perfect. For babies, when babies are younger, they measure their head and they see how their head grows, and they'll put them in percentiles for their head size. So if they're in the 50th percentile, they're average. If they're in the 99th percentile, obviously they're above average. So you guys know what percentiles are. This is nothing new. But you didn't realize that you're going to do them in stats and you're going to learn how to find them. They're really easy. The pth, just like nth, I don't know why I guess they use p for percentile, but like the p percentile of a distribution is the value with p% of observations less than it. So if you were in the 99th percentile, 99% of people were not as smart as you. So you were in the top percentile. Okay, I'll flip my page. Using the STEM plot, we see that Jenny's 86 places her 4th from the top of the class. Because 21 of the 25 observations, 21 out of 25 is 84% are below her score. Jenny is at the 84th percentile.
On the other paper, did we write Jenny was better than 3 or worse than 3? I don't have the notes printed out.
She did better than all but 3.
Oh, okay.
All but 3.
That's why I was messed up.
That's okay. All right. And again, you guys will get these notes on Thursday. I'll have them for you. They're sitting on my desk right now, or my table. All right. So finding percentiles. Here are those scores again of Mr. Pryor's statistics class. There is that STEM plot. So use the scores on Mr. Pryor's first statistics test to find the percentiles of the following students. So we're going to talk about Norman, who earned a 72. So what you want to do is how many below over the total number of test takers. So Norman had a 72. How many people were below that? 1.
1.
Out of? How many total took the test? 25. Which makes Norman in the 4th percentile. Katie scored a 93. How many people are below Katie if she scored a 93? Below her.
24.
24 out of 25 total, which puts her in the 96th percentile. Now look at this carefully. She is the smartest one, but only made it in the 96th percentile. Does everybody understand that? So that number is just based on whatever out of how many. Okay.
I'm confused.
What? Who?
Me, Haley.
Why?
I'm confused on where you're getting these numbers from.
Okay. What's your highest score?
93.
93. That's hers. So how many would be below her?
Oh, okay. I get you. And then you just divide how many are below her by the total.
Yes. And Norman, Norman had a 72. The only thing lower than that's a 67. So one.
Oh, okay. Yeah, I get it now.
All right. So the 2 students who earned scores of 80. So now we look, here's the 80. We don't worry about anything other than these scores right here. So how many were below 80? 12. So we would do 12 out of 25. And both of them would be in the 48th percentile. That's it. So that's how you find percentiles. It's really, really simple. Okay, remember it's always the number below what you want. All right, cumulative relative frequency graphs. There are some interesting graphs that can be made with percentiles. One of the most common graphs starts with a frequency table. For a quantitative variable. For instance, the frequency table summarizes the ages of the first 44 US presidents when they took office. So how do we find relative frequency? Because we've already done this. Sorry, I'll make sure it's on here.
Isn't it the number over the total?
So
It's the percent of the.
it's the frequency over the total. So the frequency was 2. How many presidents did we survey, or how many did we? Say what?
Never mind. My computer's being really far behind, so it's like everything you say is like delayed.
No, sorry. What's our total amount of presidents we did? Y'all can answer too. 44. So this gives you 4.5%. We're going to go ahead and do the other ones. So the next one would be 7 out of 44, which is 15.9%. The next one would be 13 out of 44, which is 29.5%. 12 out of 44 is 27.3%. 7 out of 44 again was 15.9%. And then 3 out of 44 is 6.8. Now that is what we did on the last test, or we talked about in the last chapter, was relative frequency. What we have not talked about is cumulative frequency. So that just means you add it together. So we're going to start with the 2 out of 44 again, which gives us 4.5. Sorry, that can go over here, 4.5%. Cumulative means you take the column that you're, or the row that you're in, and add it to the row below it. So how many presidents would be total in the first 2 rows?
9.
9. So this one's going to be 9 out of 44. So it's cumulative. You just keep adding it up, which gives you 20.5%.
Cumulative is it and everything under it percent?
Yes. So then for the next row, it'll be that row and everything below it. So 13, 7, and 2.
22.
It could be. 9 out of 44. No, 20.45 rounds it up to the 5. No worries. Thanks for asking. I can make lots of mistakes. I appreciate it. All right, 22 out of 44 is 50%. The next one will be 12 plus 13 plus 7 plus 2. Or 22 plus 12.
34.
34 out of 44 is 77.3%. The next one is going to be the 7 plus the 34 below it,
41.
which gives you 93.2%. And the very last row should always be the complete total, 44 out of 44, making 100%. All right. So to save us some time, if you want to do it, you can. I am not going to. But you can make a cumulative relative frequency graph. It's the same graph as always. So we started with age 40 because it was the least up here in our chart, to 70 right here, 40, it went to 69, but we did 70. And then on the side, it's from 0 to 100. And then you just plot the points and connect them. Okay, so I'm not gonna make it. If you wanna make it, that's fine, but I did wanna show you what it looks like.
Is frequency literally just the count out of the total?
So,
Like it's literally just one number. You can just count how many there are. And that's the
relative frequency is the count out of the total.
That's the percent, but like, is frequency just how many there are and that's it?
It's just the count.
Okay, so it's super simple.
Yeah.
I was overcomplicating it and I forgot what they were.
Gotcha. All right. So what can we learn from this graph? This graph shows gradual growth at first. It gets steeper. Then it slows down. Okay, so if we were looking at like baby head circumference or whatever, it should do that all the time. It's going to have that gradual growth at first because the baby grows really fast, and then it grows really, really fast, and then it stops. So you'll see that all the way around. It kind of flattens out. Everything ends up being around 50%. There are the ones that'll come like, you know, you have the tall kid in class or you have the short kid in class. There's always going to be those somewhat outliers, but most likely it's going to be close to normal. Okay. Suppose we only have the graph and not the table. Can we figure out what percent of presidents were between 55 and 59 years old at their inauguration? So we could, so if we're looking at this graph, what? How do you get it? Can I teach how you get it? Like I have to show you how you get this. If you just given the graph. No. Between 55 and 59. Hold on. We only have the graph. We don't have the table. Okay. Sorry. All right. So if we're looking at, what was it, 55 to 59? Is that what I'm looking at? 55 to 59. We would chart up through our graph like this, and then we would find the difference. So if they give you a graph and they ask you to find the percentage, then that's all you're doing. So if we're looking at this, we find that percentage, and I'll tell you what those are. The 77% minus the 50%. And those numbers can come from your chart, but what it's saying is if you only given the graph, you don't have the chart, so you can't look at it. You're only looking at the graph. So we would find where 55 is, that it meets it on the graph, and then we'd find where it meets 59 on the graph, and we'd subtract those two numbers, which gives us the 27, which we saw in the chart. So again, this was what we want, which was 55 to 59. And then we want to cut out what's below it. Okay, and that's exactly what we did. So a cumulative relative frequency graph can be used to describe, and I don't think that you're going to be asked to do that. I'm just telling you how to do it. The position of an individual with a distribution, or to locate a specified percentile of the distribution, as the following example illustrates. All right, so this will help you with that. If you didn't get it when I just did it, because we didn't draw the graph, so that's my fault, I should have drawn it. But you have an example right here that shows you exactly how to do it. Okay. So here's that graph. It's the same one. This is why I didn't draw it. This is the graph that I sketched and said we're not going to draw because it always does it later on. Okay. Was Barack Obama, who was first inaugurated at age 47, unusually young? So how would we find that? How would we find it? What's his age? Right there, 47. So we're gonna find 47 on the graph. So it's probably like right here-ish. And anytime you do this, it's gonna be an estimate unless it actually has like the little tick marks on it, and it won't. It'll always be an average or an estimate. And then we're gonna go across and look. What percentile is he in?
Like roughly the 10th percentile.
Probably a little more than 10. If I draw a little closer to 45, again, I don't have it's just an estimate, okay? So the book tells you it's about 13%. I might have like 16% right here. That's not terrible, okay? So I'm gonna go with what I have. He was approximately 16% younger. I'm sorry, don't put younger, 16%, which has only 16% younger than him. So does that mean that he was relatively young or not? Yes or no? Yeah, absolutely. Only 16%. So he's like in the 16th percentile. That means he's in the low end. Okay. So estimate, interpret the 65th percentile. So you will have to do this, y'all. This is on your test, okay? So you have to be able to come up with the percent, and then you also have to come up with the percentile. Okay, so percentile, how much age, whatever, by doing the graph. And we're going to do a couple of those, so don't be freaked out. It's the easiest questions on the test, okay? Estimate, interpret. The interpret part is what you'll miss, and I'll come back to that. The 65th percentile. So if we're doing 65th percentile, we're going to go up to our graph. I know that between that perfectly is 70, and perfectly between that is 65. Is everybody okay with that? So there's my 65th. I'm going to draw my line as horizontal as I possibly can over to the graph. This is showing your work. So when you get your test and it asks you to do this, but show your work, this is showing your work, okay? And then I'm going to drop it down as vertically as I can possibly get it. So it's perfect as I can get it. Where does that look to be at? Like 58. So here, we're going to say it's approximately 58 years old. Would I have accepted 59 or 57? Yeah, it's an estimate, and it depends on where your line is. If your line looks perfect, then it's going to be there. So interpret this. What does the 65th percentile mean? What does a percentile mean? Not 58, but that's your age. Is it older? Yes. Yes. The way you worded it is perfect. So what, okay, say it one more time so I can say it to everybody because they couldn't hear you. I guarantee it. Okay, she said people that were 58 years old were 65% older than everybody else. That is correct. However, you want to write it as the percentile form, okay? So you want to write it as younger than. So here's how you actually want to write it. What you said is not incorrect, okay? It is not incorrect. 65% of presidents were younger than 58. Because remember, our percentiles are always going to be that and below. Again, what you said is not wrong. This is just in percentile form. Okay. Everybody okay?
Wait, so when you're finding the percentile on the graph, you just look at the left bar in this case?
All right, so if it asks what percentile was 60-year-olds, you would pop up and look over here and find your percentile.
Okay, so when you have cumulative frequency, it's just the left side
Yeah.
or whatever the percent.
Yeah.
Okay.
All right, I have about 10 minutes left. So if we go out, I have a spot that I need to get to. If we run out of time, just come back in, okay? All right, multiple choice. Select the best answer. Mark receives a score report detailing his performance on a statewide test. This is why it's important to know the way to write things. On the math section, Mark earned a raw score of 39, which placed him at the 68th percentile. This means that what? Mark did better than 39%. Mark did worse than 39%. He did better than about 68%. He did worse than about 68%, or Mark got fewer than half of the questions correct on his test.
Better than about 68.
So A, B, C, or D?
C.
Make sure you put it in percentile form. So 68% or lower than him. That's exactly what it meant. All right, Miss Munson is concerned about how her daughter's height and weight compare with those of other girls of the same age. She uses an online calculator to determine that her daughter is at the 87th percentile for weight and the 67th percentile for height. Explain to Miss Munson what this means. I'm really mean when I answer this question, so you tell me in your own words what that means. What does it mean for her to be in the 87th percentile for weight? Then what? Explain it. Yeah, she's fatter than 87% of girls her age. And again, that's really ugly, and I shouldn't say it that way, but the reason I put it that way is because you understand it a little bit better. Okay.
Is
What
that
about-
how you could write it on the AP exam?
Yeah, they'll take it. It's not very PC, and y'all, I don't want to get in trouble for writing that or anything like that, but that helps me, like, it puts it in perspective for you. It's like layman's terms, if that makes sense. All right, what about her height?
Taller than 67% of girls her age.
Perfect. All right, questions 3 and 4 relate to the following setting. The graph displays the cumulative relative frequency of the heights, the length of phone calls made to the mathematics department. So right here, this question looks like a test question. Okay, looks like a test question. We shouldn't be on our phones. About what percent of calls lasted less than 30 minutes? Less than 30 minutes.
Like 50 something. Low 50s.
How do you get 50s? What do you got to look at?
On the bottom, 20 to 30 is like a flat line.
Okay, so less than 30 minutes, we're going to look at 30. We're going to try to go up as much as we can, and then we're going to go across the best we can.
Oh, never mind.
It's okay. It's okay. That is showing your work. Remember that. I told you on your test, that'll be showing your work. So about what percent lasted less than 30 minutes? So all of this is how much?
Like 62.
Right, yeah.
62.
Or probably like 65 something. I
Yeah,
was looking at it wrong.
All
60
60s.
to 80. So probably around 65, but I'll give you the 62 as long as you've thrown it. What about 30 minutes or more? How would you do that? So 30 minutes or more. How do I figure out this side of the graph?
Find the same thing and then like do the same thing at the 45 and then find the difference between the two.
You don't have to. What can you do?
Subtract 65 from 100.
Yeah, because you already have the 65. If you didn't have the 65, that'd be a perfect way to do it, but you already have the 65, so that gives you what? Anybody? 35. And that's it. Since you already have the 65, use what you have. I mean, if you want to subtract it and find that other one, but it's pointless to do that. Estimate Q1, Q3, and IQR. Y'all, this I'm telling you is on the test. It's on the test. How would I do that? Because I don't have values. So how do I know about Q1, Q3, and IQR?
Can you use like the value dots
What you mean?
on the line? You can kind of use that to find the median.
Uh-uh. It's easier than that. What
Can
else?
you go down to 25% and do it that way?
Yeah.
Yeah.
Yeah. So Q1 is 25%. Where's Q3 at?
75.
Mhm. So we're gonna find those on the chart up there. And again, you would just go to your 25. So here's 30, halfway is 25. When we draw,
How did you get 25 and 75?
because when we have our box plot, this is our minimum. This is 0%. This is 25. Your median is at 50, 75, and 100% of that
Okay.
is included. All right, so do that for 25. Here's your 70, 75. You're going to do it as well. Your Q1 estimate is approximately 13. Your Q3 estimate is approximately 32. And then how do I find IQR?
Just subtract 1 from 3.
So 32 minus 13 gives me 19. All right. I'm going to stop this one for right now, and I'm going to go out and come back in. So that way I'm not breaking up. Like I'm at a good stopping point. So come back in and I'll finish the rest of it.